So the second derivative test that you're going to see here, it goes by different names. And one of the key parts to this test is it's a simple one, and it is just saying that we're going to take our second derivative with respect to x and multiply it with our second derivative with respect to y. Now, what I want you to do is we're not going to worry about the actual values for a moment. I just want you to think about what that would mean if we had a positive and a positive, right? If a second derivative is positive, it means we're concave up and we're concave up. And if they're both concave up, as we saw in the previous problem, this means we have a minimum. And also a positive times a positive makes a positive. All right. Now, what if our second derivative with respect to x was a negative value and our second derivative with respect to y was a negative value? Well, then that means we're concave down and concave down, which means we have a maximum. And similarly, a negative times a negative makes a positive. So the way we remember this test so far is whenever you do a problem, if your second derivative test turns out to be a positive value, go away calendar, go away calendar, go away calendar. Okay, so let's try that again. So how we do the second derivative test is whenever the test ends up being a positive value, whenever it's a positive, if I could spell the word positive, T-I-V-E, there we go. If it's a positive value, then we know it is either a max or a min. And then similarly, if one of our values was negative and the other value was positive, or vice versa, that means we have one concave down, one concave up, which results in a negative value, and we know that this is a saddle point. So that's it. That's how you remember this rule. It's very simple. You say if my answer to the second derivative test is a positive answer, then I know I have a max or a min. And how do you figure out if it's a max or a min? Well, you go back and look at any of the values. Whoops, trying not to do that, Ben. Let's try that again. You look at any of the values. That worked. And you say, okay, that's a positive number, which means I'm concave up, which means I have a min. If any of the values was a negative, then that means it is concave down, which means I have a max, and we're done. And if your answer is negative, you're done. That's all you need to think about. Answer is negative, saddle point. All right? Now, what is this test saying? Well, we're not going to go into all the calculus behind this, but there is a third term, second term, third derivative, there you hear, the interaction term. And what this is saying, let me make up some test values. Let's just give an example. Let's say this was a 2 and a 2, and then our derivative with respect to x then y turned out to be 4 squared. Well, then our d-test would be what, 4 minus 16, and that ends up being a negative 12. So what does it mean if your answer is a negative value? Saddle point, right? Just like those rules we just came up with. And that's it. That's all we do with this is you just say whatever my second derivatives turn out to be, if it turns out to be a negative number, my answer is a saddle point. If, for example, this was the situation, so I'd have 4 minus, squared. Right, it's built into the equation, squared. Okay, so if it was 4 minus 1, that'd be 3. That is a positive number, and since it is a positive number, then that means I have a max or a min. So now I go back and look at any of the individual values and I see it's positive, which means my graph is concave up, which means that this is a min. So that's how you use the second derivative test. Now, there are all sorts of fancy schmancy ways of writing this rule out, and it gets very complicated. One of those examples is right here, where you can see what the way it's written out is if the derivative test is greater than 0 and f of xx is less than 0, then it's a max, or then it's a min. That's exactly what we just said. We just did it using logic instead of this fancy schmancy notation. Okay, now, and again, if your d is less than 0, then you know it's a saddle point. Yeah, that means negative. Okay, the one thing I want to point out is it will never equal 0 in this class, but if it did equal 0, then this test fails. If your second derivative test equals 0, then you got to use something else. There's other tests out there, or you could just look at the graph or make a table of values and figure it out from there. But the big idea, we just covered it. Positive values, min or max, look back at either of the individual second derivatives to figure out whether it's concave up or concave down. If it's a negative value, saddle point every single time. It doesn't matter what these are. All right, so let's do one. Here we go. So first things first, how do you find mins or maxes? Well, the exact same way you've always done it. You take the derivative with respect to x. You take the derivative with respect to y. You're going to set both of these equal to 0. And I will point something out here. One of these is easier to solve than the other. Haha. Right, so don't just do the problem in the derivative with respect to x first because it's on the left. Look, use your brain, right? Say, look, solving this for x is super easy. That's 0. So now I can take my x equals 0 and sub that in over here, and I'm going to get 0 equals 2 times 0 minus 4y. Now, I made reference in the previous problem where I talked about the value didn't come from any substitution. Well, this one is coming from substitution. I know when I sub in x equaling 0, I'm going to end up getting this, which means y equals 0. So therefore, I have my ordered pair. These get, or ordered triplet, two of the values. These get paired up because this y equaling 0 came from me substituting in x equaling 0. So I have 0, 0, something. Now, how do I get my z value? I take both of these, sub them back in to the original equation. So that would be what? 0 minus 4 times 0 times 0. So that makes 0. So therefore, the max, min, or saddle, the critical point, is at 0, 0, 0. Now what? What is it? Is it a min, is it a max, or is it a saddle? Well, here comes the second derivatives. Second derivative with respect to x. So let's see. That would be coming from this equation right here. Let me clean this up a little bit. Kind of make this a little less noisy. Okay, so coming from my first derivative with respect to x, second derivative, what would that leave us with? Just 2. And the second derivative with respect to y, that would be 0. And now, for the d-test, I need the derivative with respect to x, then y. And hopefully you realized when you were doing the partial derivative homework that whether you do the derivative with respect to x, then y, or if you do it with respect to y, then x, you get the same thing. So pick whichever one's easier, right? So me personally, look, the derivative with respect to y is just negative 4x. So therefore, the derivative of that, going from here, the derivative with respect to y, then x, well, so that has x to the negative 1, bring the 1 out to the front, that's just going to make it negative 4. Great. So there we go. Now I've got my 3 derivatives. So now let's use the d-test. What does the d-test say? Well, it's x then y. When we say this notation, what we're really saying is just take your x value, take your y value, sub them in. So if there were any variables left over in our equation, everywhere I have an x, I'd be replacing with a 0. Everywhere I have a y, I'd be replacing it with a 0, and so on and so forth. So I'm going to use the d-test at the x value of 0, the y value of 0. And I'm going to do the second derivative with respect to x times the second derivative with respect to y minus the second derivative with respect to x then y squared. So that would turn into 2 times 0 minus a negative 4 squared. And what does that mean? What does that mean? Well, 2 times 0 is 0, minus negative 4 squared is 16, so it's minus 16, so it's negative 16. So what does this mean? Since I have a negative answer, what does that mean? This is a saddle point. So, this is a saddle. Fantastic. There is a problem. Now, we're going to go on in the next video, and we're going to do another one, a little more complicated, a little more interesting. I hope we're getting it.